Hello everybody, welcome to this new video from Guidance Education channel. In this video, we are going to discuss combination of capacitors. That is, what will happen when more than one capacitor is used in a circuit. We may say, broadly, capacitors may be connected in two different ways. They may be connected in series or they may be connected in parallel. In this video, we will discuss combination of capacitors in series. We will also see its merit, that is, whether connecting capacitors in series is beneficial to the circuit or not. But before we start the class, please watch the video completely so that you get all points cleared, and if you think the video is useful, do like the video, share the video with your friends, and also leave your feedbacks as comments in the comment box below. As I keep telling you, your comments will help me understand your thinking about the video. If you have not subscribed my channel, do subscribe it now. Press the bell button and all button for notification of more videos like this. Thank you very much. I am Anandavalli. Come, let us start the class. The symbol of capacitors in a circuit is two parallel lines. I will show them slightly apart. This is the first capacitor C1. This is the second C2. This is the third one C3. The capacitance also we use the same symbol C1, C2 and C3. When we connect the capacitors in series, the second plate of the first capacitor is connected to the first plate of the capacitor C2 and the second plate of C2 is connected to the first plate of C3. The first plate of C1 and the second plate of C3 are connected to a battery through an external circuit. The positive terminal of the battery is connected to the first plate of the capacitor C1 and the negative terminal of the battery is connected to the second plate of C3. Let the potential difference of the battery in the external circuit be equal to V. Now let us consider that C1 develops a potential difference V1, C2 develops potential difference V2 and C3 develops potential difference V3 due to the charging of the capacitors. The first capacitor develops a charge equal to positive Q. Second plate of the first capacitor develops an equal negative Q. The first capacitor now induces charge in the second capacitor and the second capacitor induces charge in capacitor 3. The second and the third capacitors also will develop the same amount of charge, that is Q. In other words, C1, C2 and C3 will have the same charge equal to Q. The total charge in the system of these three capacitors will be only capital Q because the battery in the external circuit provides only a charge equal to Q. For charging the other two capacitors, no additional charge is drawn from the battery. Due to charging of C1, C1 induces charge in C2, C2 induces charge in C3. So the total charge in the system of three capacitors is only Q, but their capacitance is different. Their potential difference also is different. We have already seen that the potential of the battery becomes equal to the potential of the system of three capacitors. So, V is equal to V1 plus V2 plus V3. Capacitance C is equal to Q upon V. So, V will be equal to Q upon C. What is V1, V2 and V3? V1 is equal to Q upon C1. V2 is equal to Q upon C2. And V3 is equal to Q upon C3. So substituting, we get V is equal to Q upon C1 plus Q upon C2 plus Q upon C3. Q is common. So we can write this as V is equal to Q, then within brackets 1 by C1 plus 1 by C2 plus 1 by C3. Shift Q to the left hand side. Then it becomes V upon Q is equal to 1 by C1 plus 1 by C2 plus 1 by C3. We know C is equal to Q upon V. So V upon Q will be equal to 1 by C. Now C is the effective capacitance of all the three capacitors. Since the capacitors are connected in series, we will note this capacitance as CS. S for series connection. CS stands for capacitance of a few capacitors connected in series. So 1 by CS is equal to 1 by C1 plus 1 by C2 plus 1 by C3. When the reciprocal of the capacitance of each capacitor is added up, we get the reciprocal of the effective capacitance. Remember, for resistors connected in series, the effective resistance Rs is equal to sum of the resistors. That is, if two resistors with the resistance R1 and R2 are connected in series, the effective resistance Rs will be equal to R1 plus R2. In the case of capacitors in series, it is different. Okay, now we will take a small example and see how the magnitude of the effective capacitance is affected when capacitors are connected in series. Let us suppose we are connecting three capacitors C1, C2, C3 with capacitance C1 equal to 2 microfarad, C2 equal to 3 microfarad, C3 equal to 4 microfarad are connected in series. Their effective capacitance 1 by Cs will be equal to 1 by 2 plus 1 by 3 plus 1 by 4. LCM will be 24 and the value will be 12 plus 8 plus 6 upon 24 equal to 26 upon 24. So effective capacitance 1 by Cs is equal to 26 upon 24. So Cs will be equal to 24 upon 26. As you can see, this will be less than 1. Least capacitance in the circuit is 2 microfarad. So when capacitors with different capacitance are connected in series, the effective capacitance is less than the least capacitance in the circuit. So remember this. What is the use of this connection then? Capacitance is getting reduced. There are certain circuits where we have to reduce the capacitance. So this type of connection, that is capacitors can be connected in series where there is a need to reduce capacitance. Okay? If you think the video helped you, do like the video, share the video with your friends and also leave your feedbacks as comments in the comment box below. If you have not subscribed my channel, do subscribe it now and support me. Press the bell button and all button for notification of more videos like this. Thank you very much. We will discuss combination of capacitors in parallel in the next video. Till then, bye. Take care.